45 is asking, a large wooden turntable in the shape of a flat uniform disc has a radius of 2 meters and a total mass of 120 kilograms. The turntable is initially rotating at 3 radians per second about a vertical axis through its center. Suddenly, a 70-kilogram parachutist makes a soft landing on the turntable at a point near the outer edge. A. Find the angular speed of the turntable after the parachutist lands, assuming that you can treat the parachutist as a particle. And then B. Compute the kinetic energy of the system before and after the parachutist lands. Why are these kinetic energies not equal? Well, I'm just going to write down all of our givens. So we have that before on the wooden turntable. So before, R equals 2 meters. W1 equals 3 radians per second. And then M equals 120 kilograms. And W1 is the axis of rotation, by the way. And then after, we have that W2. The axis of rotation is not what it, that's what we're finding. And that will be in milligrams. And then we have meters equals 70 grams. And then the soft landing is friction forces between the parachutist and the turntable are internal forces. Okay, so A, take the turntable and the parachutist as a system. And note that there are no external forces producing torque about the axis of rotation. So then the angular moment is conserved before and after the landing. So I'm going to be using this equation, W1, equals I to W2. And then I1, the flat uniform disk, the equation for that is 1/2 mr squared. So just plug in, plus mr squared, plus mass r squared. So plug in all the values that were given to us. We get 240 plus 70 times 2 squared equals 240 kilograms. Okay, so for I2, we have the same equation, and we get that, the same equation but plus mass r squared, and we get that 240 plus 70 times 2 squared equals 520. Kilograms. And then W2 will equal a ratio of I1 and I2 times W1, which will equal 240 over 520 times 3, which was given to us, which will equal 1.385. And that is part A. And then for part B, K1 is denoted by the equation 1/2 I1 W1 squared. So we just plug in all the stuff we have times 3 squared, which will equal 1080 joules. And then for K2, we have the equation 1/2 center squared, which will equal 1/2 520 times 1.385, which we found before, squared, which will equal 498.74 joules. And just the kinetic energy of the system is reduced due to the negative work done on the parachutist, but the turntable during the soft landing by the and the turntable. So as just a reminder, A equals 1.385 radians per second, and then B, K1 equals 1080 joules, and K2 is 498.74 joules.